Welcome everyone to a cold and cloudy and rainy and snowy and miserable day, at least in Michigan. I don't know how it is where you are, but it's pretty miserable here, but it's great in Arizona. So that means it's a great night for an online viewing session with the Kalamazoo Astronomical Society. And if you didn't know, if you didn't catch the graphic at the beginning, we are celebrating our 90th anniversary this year. We got off to a fantastic start last night with Professor Sarah Seeger. If you missed that presentation, we'll try to have it online in a couple of weeks or so, as soon as I find the time to edit the thing. But we do have clear skies out at Arizona Sky Village. We'll take a look, see what conditions are like out there shortly. But again, I want to welcome you to another online viewing session with the Kalamazoo Astronomical Society. My name is Richard Bell. I am your host for this evening and also the president of the Kalamazoo Astronomical Society. So let's go ahead and jump right into it. I'll go right back to my PowerPoint here. And so again, this is our online viewing session for January 10th, 2026. And we'll give you the basic intro here if this is your first time joining us. I know many of you have been with us before and have heard this many times, but here it is for the new folks. So here's the home of the KAS Remote Telescope. It's in Peishi Observatory, which is a 20 by 20 roll-off roof observatory located on the property of KAS member Mike Patton, who I do believe is joining us this evening. From Arizona Sky Village, where Peishi Observatory is located. And I always forget to turn on my little laser pointer here, but that, of course, is the remote telescope sticking up right there. That's actually the 20-inch, and there's the Takahashi right there. And we have our weather station. We'll check the weather conditions here shortly. But on the back here, we have this little funky looking box, and that is our all-sky camera, our Peishi all-sky camera. And as I mentioned, even as late as last season, we recently upgraded. And so we replaced our old S-Big all-sky camera, which had a little tiny CCD chip with a more modern CMOS camera. And so we use a ZWO ASI 183 MC for our camera. We have it attached to a Fujinon 2.7 millimeter f1.8 fisheye lens. And this was all put together by Jim Kurtz, but we got the idea from fellow ASV resident David Churchill. He has the identical lens and camera, and we were so impressed with his images, we decided to kind of adopt the same thing. So let me switch shares here. We'll see if I can find my browser. Oh, there it is. And here is the all-sky camera. Now, of course, you can check out the all-sky camera whenever you want, day or night, just not during the summer because we turn it off in the summer. And you can go to our web page. Of course, the menu is the same from every page. Just go to the remote telescope menu and pull up the Peishi all-sky camera, and it'll take you to this page right here. And so let me give you a quick tour of the sky above Arizona Sky Village right now. It sure does look a lot better than it does here from Michigan. This little glowy thing right here kind of looks like an illuminated, I don't know, circus tent or something like that. This is the observatory of Mike Patton. This is Peishi Observatory. Whoop, you can see it just loaded, and oh, looks like maybe there's an ISS pass. That's broad enough to where it could possibly be the space station right there. Maybe if someone has a free keyboard and monitor, you can check that out for me. I don't have time to do it myself right now, but that very well could be the space station right there. I really don't know. But so this direction faces west. Of course, over here is east. This is actually the North Star right there. So go straight down. That's due north. And of course, south is down there. This little funny looking gadget there is our bird perch. That keeps birds off the dome and doing their business on the dome. And sometimes we catch some pretty interesting birds on there on the all-sky camera. So you can kind of bird with the camera during the day and check out the stars at night. So looking toward the west sky here, all the stars of summer are gone. I mean, they are just gone. There's just nothing left. Well, there is kind of Deneb there. You can see a little bit of the southern or the southern, the northern cross. That's probably Albireo right there. So we do have Cygnus and the northern cross still visible. They'll cling on for a bit longer, but we'll probably lose those during the course of the session. And we kind of move up the Milky Way here, and we can find Cassiopeia up here. This is Perseus, kind of looks like a wishbone with the Pleiades down there. We might take a look at that later. But we still have some of the stars of fall, even though we are now well into winter. We still have many stars of fall that are, visible in the evening during the fall. This, of course, is the asterism of the Great Square of Pegasus. These three stars actually belong to the constellation Pegasus. This is like the back of the horse, so there's supposed to be like a wing, going out there, but there aren't really any stars that represent the wing. There's kind of a little triangle of stars here that represent the horse's head. He is upside down in the sky. And going from this star here, there's like a leg here kind of jumping on the space station, which I think it's the space station. And then we have another leg kind of going here. And this is the head of Andromeda. And Andromeda, you can really visualize as two arcs starting from this star here called Alpheratz. The brighter arc is on the bottom, kind of like three stars here. And there's kind of a fainter arc above. And this little glow right there is the Andromeda Galaxy, which we checked out last month. And we're going to take a bit of a closer look at it this month. So we'll jump into that later. And I think you could even see a hint of the zodiacal light here. It's not quite as brilliant as it can usually get, but this does look kind of like a big cone-shaped glow that is from the zodiacal light, which is basically sunlight reflecting off dust in the plane of the solar system. And now we have the winter constellations here in full view. If you joined us last month, they weren't quite fully risen, but it wasn't winter yet when we had our last session on December 13th. But now we can see the full winter hexagon. We'll start with this star here. This is Rigel. And Rigel is the left foot of Orion the Hunter. And so you can always remember Orion with a little limerick. You can say 3 stars in a row, 2 above and 2 below. Of course, the 2 above mark his shoulders. We got Betelgeuse and Bellatrix. There's a few little stars above for his head. He kind of has like a little tiny head. He's more brawn than brains, I guess. Then we have Rigel and Saiph, S-A-I-P-H. So, if you take some Betelgeuse, your belly will do some tricks, but take some Rigel and you'll be safe. And you can see the camera reloads every 4 minutes or so. Then, of course, between the two, or the 4 corner stars, we have the belt stars, Alnitak, Alnilim, and Mintaka. We'll take a close look at kind of this region here later, but this is the famous belt of Orion, and hanging from his belt is his sword, which where we have the Orion Nebula, but we're going to save that for next month. And we do also have a shield here, kind of like a faint curvature of stars, and kind of a club kind of going up here. I kind of lose it up there amongst all the other stars up there, but it's up there somewhere. But there's Orion. So now we go from Rigel to Aldebaran. And Aldebaran is the eye of Taurus the bull, which is kind of represented its face with the Hyades here. So the Hyades is like the nearest cluster to Earth. It's like just 300 roughly light years away. It's actually so big in the sky, we can't even fit it with the Takahashi, because one of these days, maybe we should try the Hyades, but I know we can't quite fit the whole thing in there. It's so big, not even with the Takahashi. And so the star Aldebaran is not technically part of the cluster. It's kind of in the background, I think. Then on the back of the bull, we have the Pleiades. And you can kind of imagine, again, here's the face. There's like a horn that goes out there, horn here, and kind of maybe a trail of stars. But sometimes you can envision kind of like a leg here and a leg here, like he's bursting through the sky. So we go from Rigel to Aldebaran to Capella. Capella is the goat star, and there's a little triangular asterism near it called the Kids. So we have Auriga, the charioteer, who's making off with like some goats, like Capella and the other goat stars. So there's kind of like an L shape here for the chariot. and this is the head of the charioteer. And why is he making off with some goats? We don't really know. I think that's been lost in mythology. Then after Capella, we go to Castor and Pollux. You can really say Pollux is technically the corner of the hexagon here, but Castor is the more interesting of the two, even though it's a little dimmer, because it's a really cool sextuplet system. Nothing you can really enjoy with a telescope, but it's really, really cool nonetheless. So Castor, he kind of has these longer arms and a short body and these little stubby legs, while his brother has these little kind of shorter arms. So they're kind of like holding hands here. And he kind of has this shorter body, but these long legs, kind of like that. And of course, you see a really bright object right there, but that is none other than Jupiter. So there's the planet Jupiter. And then we go to Procyon, which is part of Canis Minor, the lesser dog. It's basically Procyon and Gomisa. So that's pretty much it. Just two stars there for the little dog. And then we go to the brightest star of the night sky. It doesn't quite look as brilliant yet because we have a little bit of, atmospheric extinction going on, dust and gas in the atmosphere and that kind of thing. So it'll get brighter, but we don't quite have a full view of Canis Major yet. So we're still waiting for the full bit of constellations in the winter hexagon to rise, but all the stars of the winter hexagon are visible. So there's our quick tour of the night sky. So let's jump right back into my PowerPoint here. I always have to switch back. There we go. So, of course, as usual, we will start with our first telescope of the night, which is always the Takahashi. I think one time we did start with the 20-inch, but we pretty much always start with the Takahashi. And it's basically a 4-inch refractor, very good quality telescope, although we've had a few collimation issues with it. And we use a Moonlight focuser, a Moonlight Nightcrawler 2 focuser, very, very good focuser. And our camera is an SBIG STX 16803 CCD camera at the current time, but this year we will very likely upgrade our cameras to more modern CMOS cameras. In a way, this chip is bigger, but the newer cameras have less noise and more sensitivity. So we try to keep everything current and up to date. So after 10 years of using this camera, we're going to go ahead and upgrade it. And eventually we'll sell them. So if you think you might want a good SBIG STX 16803 camera, let us know. We plan to sell it for a fraction of the price of what we originally paid for it. So it is a full frame camera, roughly 37 millimeters square, 4,000 by 4,000 pixels, which seems kind of low today. But it is a really, really great camera. We'll definitely show what it can do here later. Okay, so our very first target of the night, well, I won't quite introduce it just yet. Let me switch you back to the browser so I can type it in. So let me go to the next tab there. And here we have ACP, which is the Astronomer's Control Panel. And we'll have to replace this pretty soon as well, because Bob Denny, who created ACP, the Astronomer's Control Panel, is retiring. In fact, he didn't even send us a renewal this past October like he usually does, because eventually his support for this program will end. So this will very likely be the last season that we're going to use ACP to do these online viewing sessions. So that'll pretty much be it after this season, because we'll have to switch to something that's, kept updated, because this will no longer be updated, and eventually it might not be supported at all. So let me pop on the single image window there. I haven't done that yet. And I'll type in our very first target there. It's going to be NGC 7822. Hit get coordinates there. Kind of hard to forget this time. And this is a nebula, so let's go ahead and go crazy. We'll do, let's go ahead and do 10 minutes. Get rid of that extra zero there. We'll do 10 minutes with our hydrogen alpha filter, because it is a pretty nice nebula. And we'll go ahead and hit acquire image. And back to the PowerPoint there. So, yep, we're doing NGC 7822, the Brain Nebula. And this was discovered by John Herschel, the son of William Herschel, on November 16th, 1829, using his 18.3-inch reflector. And the NGC list, incidentally, is a list of deep sky objects compiled by John Louis Emile Dreyer in 1888, based on the observations of William and John and Carolyn Herschel. And so he cataloged it as, or at least John Herschel cataloged it as H2302 and described it as the following: the central part of what I am positive is an enormously large but extremely faint nebula of a round figure, though I cannot trace its limits. And the Swedish astronomer Sven Cederblad listed it as Cederblad 214 in his 215 Bright Nebulae catalog in 1946. And then the American astronomer Stuart Sharpless listed it as Sharpless 2-171 in his 1959 catalog of 313 H2 regions, basically emission nebulae, much like the Brain Nebula or the more famous Orion Nebula, and so on. So let me give you a general idea of where we're looking in the sky. So here we have the familiar constellation of Cassiopeia. Here we see it upside down. Of course, on the L-Sky camera, it looked very much like a W, but here, using a Starry Night Pro, it looks like an M. So we see it upside down. And of course, you can see like the more famous Heart Nebula and Sol Nebula, which we did a couple months ago. And near Cassiopeia is Cepheus the King, which looks like a house, very much like a Riga, but the shape's a little bit different. And you can see the outline of roughly where the Brain Nebula is. So here it is with a little more specificity. So again, you can see kind of the tip of the house of Cepheus and the rest of the roof. And so it's just a little off in this direction, but off the top of my head, I can't remember what direction this is, but that's where we find NGC 7822, the Brain Nebula. All right, so let's go ahead and see how we're doing. We'll hop back to ACP. We're going to be hopping all over the place if you've ever done one of these before. And it does look like we've already attained a guide star, and we are tracking. And let me give you a behind the scenes tour. We can do a weather update too. So there's our guide star. You can see we're doing our 10-minute exposure. I'll fill you in on that shortly, but it is, of course, clear, as we saw with the All-Sky camera. It is calm, which means the wind is under 5 miles per hour. In fact, it's a very nice 1.4 miles per hour. It was forecast to be a bit higher, which always makes us a little nervous because when it gets close to 10, the telescope tends to get a little on the shaky side. And you can see the humidity is 56%, which is pretty high for out there. It's been actually a very rainy week out at Arizona Sky Village. If you checked out the All-Sky camera earlier in the week, it just looked absolutely dreadful until yesterday. And then tonight looks pretty good. Although according to the clear sky chart, the scene for tonight looks pretty icky. But hopefully the guiding and the images will be okay. And you can see that the temperature, it's actually pretty comparable to here, 34.2 degrees, and here in Kalamazoo, it's about 32 degrees. So temperatures are very similar right now. So, yep, this is Clarity 2, which is what we have connected to the weather station I pointed out earlier. And, you know, maybe from time to time, we'll go in and check the weather. Below there is M1 Oasis, which is what we use to open and close the roof. That's pretty simple. And then this is Maxim DL. There are later versions of Maxim DL, but since we're going to switch to a non-ACP program, we don't need Maxim really anymore, and it's so expensive, it's not worth getting. So if you use ACP, you have to use Maxim. That's just kind of the way that it works. So Maxim is what we use to control the imaging camera and the auto guider camera, which is both working right now. And of course, over here, as you can see labeled, this is ACP itself, and you can see I, Richard Bell, am currently connected to the remote telescope. So there we go. So we still got quite a ways to go. So let me go ahead and stop sharing there. I will allow everyone. Oh, you actually could already unmute yourself. I didn't uncheck that earlier. So you can now unmute yourself if you have any questions you would like to ask me directly, or if you're shy, you can just post them in the chat and so on. Oh, and I see one question in the chat is what is the Atlas software that you use? Um, I mentioned I use Starry Night. That's kind of for the wide field shot, but for the more specific Atlas, with the white background, that's actually a scan from Sky and Telescope's Jumbo Pocket Sky Atlas, which I highly recommend. I know some people tried to order it last month, but they were currently sold out. But once Sky and Telescope gets those back in, I highly recommend the Jumbo Pocket Sky Atlas. They have a smaller version too, which I also have, but the Jumbo one's a bit nicer because it's bigger. And according to Tim Kurtz, it was an ISS pass. It was magnitude minus 2.9. Didn't look that bright. Okay, 2.9. That sounds pretty good. Okay, I'm out of material. Anybody else have any questions or just want to say hi or have any comments or anything? I'll wet the whistle here. Oh, it's going to be an extra quiet crowd this evening, I can see. You guys are making it pretty hard on me. This is rough. Oh dear. Okay, well, let's go ahead and hop back to ACP. We'll kind of check our progress here. So we're roughly halfway in. The tracking looks pretty good. And I bet so you can see the space station is gone. And can't really see it, but of course, I mentioned this is the observatory. This is Mike Patton's house over here. I don't know how he lives upside down like that, but somehow he does it. And this is his new neighbor as of like last season or toward the other a couple seasons back. At first, he was very bad about having this bright light out his window there. At least it looked bright, in a 1 minute exposure. But he's gotten better since then. But the house really lit up in the distance there. Shame on him. That is the house of year-round ASV resident Rick Benno, who has a 20-inch or no, a 24-inch plane wave compared to our 20-inch. And for the most part, there's not really any light pollution at all. There's a little bit of a glow here. This is probably more from neighbors than it is from any town because there really is no significant town nearby that gives you any light pollution. And you can see the horizon's kind of dusty tonight, which is a little surprising considering all the rain they got. You'd think it would have kind of beat the dust down, but there you go. And oh, look at this. It looks like we had some kind of flare here. We can actually go to a larger version there. Oh, of course, it's not there now. Oh, shoot. Well, I missed it. So if we, oh, hang on. Go back there, hit reload. Well, it's still there, but you can see a bit of a trail here, then it brightens and then dims back down. So looks like some kind of satellite or space junk briefly flared. We used to get those all the time with iridium flares, these kind of cellular satellites, used for global cell reception. But they're all been deactivated and replaced, and the new versions don't really flare like the older versions did. They were fun, but Starlink satellites are just pure evil. Not only are they bad for astronomy, they're bad for the environment because they burn up in the atmosphere fairly frequently. So dumping all that stuff in the atmosphere is not good. So they are just not good in general. So we're getting there. We're almost done. And I did kind of scan through the chat here. It does, again, look like not only do we have members from our own group with us and from other folks around the state of Michigan and around the country, but around the world too. So it's always great to have people here with us from all over the world. I'm glad we're kind of building a following on almost every continent around the world. That's pretty awesome. So just kind of scanning through the chat here real quick. We're almost done. Pardon me while I chew on my ice. We're getting there. Boy, these 10-minute shots are rough, especially when people are so quiet.
Hey, Richard, I got a question for you.
Oh, wonderful.
This is Kevin from Maine talking. You mentioned about the space station. NASA used to have a link called Spot the Station, but then they shut it off. I guess the budget cuts.
Yeah.
Is there another thing we can sign into so that way we can get these notices when it's going to pass overhead where we live?
Yeah. I've always preferred Heavens Above myself.
Okay.
Here I can where I have that bookmarked here somewhere. Here it is. I think I'm still sharing. So this is Heavens Above. So here I can pop that into the chat. If I can find it. Oh, here we go. Oh, no, I already had it open. Stupid. Jeez. There we go. So that's the link for Heavens Above. This is what I use to look up the space station. You can see I have it logged in from Owl Observatory, so I can tell people at our public observing sessions when the space station is going to pass overhead.
Okay.
And I don't know if it was any higher here. No, it was even lower here. Boy, a really different part of the sky, too. I think that's roughly the same time. But there we go. Well, I think we're done. Oh, let's go back. So you can see our thumbnail image here. And what's going to happen is it'll do like a final plate solve. You can see it's counting stars. So 10,107 image stars found. It's a quick counter. And pretty soon here, it'll do a final plate solve. And what's happening is Maxim DL does a really quick thumbnail. And then then ACP will have Maxim process a higher resolution version, which is the one that we'll look at. And then ultimately, you'll be able to download the full resolution version later, just a little bit process though. Okay, so it did a final image solve. 432 stars were matched or solved. And here we go. Here's our first target of the night. So if you're not unmuted, unmute yourself because I love to get the natural reaction of everyone. So here is NGC 7822, the Brain Nebula. Looks a little dimmer in the thumbnail, but it'll be a little better in the processing. But there we go.
Oh, so lovely.
Does it look like a brain?
A little bit.
So this is a faint one, but that's what's nice about the online viewing sessions is we can kind of look at stuff you could never really do with a telescope out in the field. There we go. NGC 7822, the Brain Nebula. And given a distance of 2,900 light years and a diameter of 3 degrees, its true physical diameter is about 150 light years, which is pretty average, I think, for emission nebulae like this. And so Cedarblad 214 is the brightest portion of Sharpless 2-171, one of the other designations for this region. And it's centered on the young star Berkeley 59, which I believe is this one right there, which is a knot of about 40 massive stars. They're only a few million years old, and many are pre-main sequence, which means they don't yet fuse hydrogen into helium in their cores. So many of them are probably what we call T Tauri stars, kind of a youthful protostar stage. The sun was once a T Tauri star. The cluster includes what's called BD plus 66 1673, one of the hottest stars discovered within 1 kiloparsec of the sun. An eclipsing binary system consisting of an O5V star with a surface temperature of nearly 45,000 Kelvin, which is 80,540 degrees Fahrenheit. Compare that to the sun's surface temperature, which is 5,800 Kelvin, about 9,000 degrees Fahrenheit. So it's a really hot star. And it has a luminosity of 100,000 times that of the sun. And of course, that star is one of the primary sources for illuminating and shaping the nebula. Like, you know, for the Orion Nebula, it's the trapezium. But for this nebula, it's BD 66 1673 in there somewhere. All right, hopefully everyone can still hear me because I just got a note that my internet is unstable, even though we just kind of had it fixed the other night, but whatever. Okay, so there we go. There's NGC 7822. And don't forget, you'll be able to download the full resolution later, which will be a little better processed than what you saw there. So maybe it'll look a little comparable to the thumbnail, just maybe a little bit bigger there. Okay, next. I'll close that. Let me go back to the, before I do that, let me go to our next target. So we're going to do CR 39. This time we can just do 5 minutes because it's pretty bright with the luminance filter. And I did hit a get coordinates. I'm just going to do it again just to make sure I don't forget. And hit acquire image there. And we'll see if it's going to take off on me. Take off in a good way, of course. I think I hit it. Oh, there we go. We're slowing. Okay. So we're good. All right. So our next target is Colander 39, abbreviated CR 39, also known as the Alpha Persei cluster. And so the Colander catalog contains 471 open clusters and was published by a Swedish astronomer named Per Colander in 1931. Not all of them are open clusters. Like, for example, there's CR99, the coat hanger, which we looked at last month. That's just a random grouping of stars that just so happens to look like a coat hanger. And it's also known as Below 20. The Malot catalog contains 245 star clusters by the British astronomer Philibert Jacques Malot and was published in 1915. And so the brightest member lies between Alpha and Delta Persei, which is the heart of the segment of Perseus. So we're looking right toward the kind of main part of Perseus here. We have, again, this wishbone shape we outlined earlier. That's Algol, the famous eclipsing binary star. This is kind of the short end of the wishbone. And so there's kind of like this whole cluster in this region here. So we were over here at the Brain Nebula. Now we're going to hop over here to the Alpha Persei cluster. And then I mentioned it's between Alpha and Delta. Of course, I assume Murphec there is Alpha. And there's Delta. So yeah, you can see the cluster is kind of between these two here. And so this was discovered by the Italian astronomer Giovanni Battista Hodierna, and who first logged this object before 1654. But of course, it's likely been seen since antiquity, since it is part of a very prominent constellation that, of course, maybe people would have different names for, but it's been observed throughout history. But Giovanni was the first to really log it and catalog it. And in 1910, Arthur Eddington first described it as a widespread moving cluster. And I can hear some work going on in the background with the telescope there. So let's hop back to ACP, see how we're doing. Of course, the telescope has to slew. Looks like we're getting the pointing update. So it may have had to have slewed to the other side of the sky, even though we're roughly, it may have been on the other side of the meridian, so to speak. So it took a while to slew. And now it'll hunt down a guide star. We can see if we can kind of catch that in the process. Oh, it just caught, I just missed it. So the guide star just got settled there, or the guider got settled. And now we're in the process of guiding. Oh, and the wind has gone up by like a fifth. Now it's 1.6 miles per hour. I think the humidity has increased. Oh no. There's never dew out there though. It's like never dewy. So that is not an issue. So everything looks pretty good. And we'll hop back to ACP. Let's see if there's anything else interesting in the sky. Remember last month when we met on December 13th for a viewing session, that was during the peak of the Geminid meteor shower, but we didn't catch one meteor on the outsky camera. And I tried to check later, but I don't believe we did then either. So sometimes they're faint. And of course, it was totally crummy here again. It's been a very cloudy winter. Oh, and you can see that neighbor has his bright light on again. Boo, boo on him. That guy needs a curtain or some blinds. All right, so we're in the process of our 5-minute exposure. And kind of scanning through the chat here, says, what are some of your guys' favorite things to look at in the night sky? Of course, besides the planets, I love Saturn just as much as anybody. I've always been a Mars nut. I've always enjoyed when an opposition of Mars comes. I unfortunately missed the last one because it really occurred in January, which is like the worst time of the year for us to do anything astronomical outside. It's always cloudy here in January. But my favorite deep sky objects are, pretty much all the popular ones, the Orion Nebula. I like the double cluster. Probably my favorite deep sky object is the Lagoon Nebula. I've always been a fan of that one. Every time I get a new telescope and travel to a dark site, I'll observe it. Every time I get a new camera, I'll try to take a picture of it just to compare and contrast with other views I've gotten. And Sean asked, what are the starts, or is it stars with the lines? Oh yeah, stars with the lines through them in that diagram. I'm not quite sure what diagram you're referring to. So Sean, if you can like ask me, that would be wonderful. Oh, Kevin answered that double stars have lines through them. Yep. Okay. There we go. Looks like that's all the questions there. Boy. Well, we can look at ACP here for a while. It's not terribly exciting, but we'll kind of go ahead and not share here again. Not even too many people are sharing their cameras. I mean, boy. Gotta liven up here, folks. It's supposed to be an interactive program. Anybody else want to share their favorite objects to observe? Seems like a good topic. "71 people in here, and it's quiet as a mouse in here. My holy cow."
Okay, I'm going to dive in again, Richard. This is Kevin. I like to
Okay,
view,
Kevin.
I like to view the Pleiades. I know they're probably, one of the, for some it might be more mundane, but where I am up here in the north, they're one of the better things to see in the wintertime. And depending on the night sky you get, the clarity, um, you get the details. I've never had the same photographing session each time, so it makes them really interesting. As to me, they change. I've also just had cataract surgery, so maybe I'm going to see them even better. So,
Hope so. Well, good. Thanks for sharing. I think you'll enjoy our next target. Spoiler alert.
thank you.
Let's see. Steve said he likes to observe comets. I like to too when they come. Eric likes the Eagle Nebula. Oh, and someone's asking about the Sea Star 30. I know a lot of people have enjoyed it. I know we have one member. I don't know if he's with us tonight, George Drake. He brought his Sea Star 30 to the picnic last August and did a little solar imaging with it. And I know another amateur on the east side of the state has a Sea Star 30 that he likes. So they're very popular. If you like to do the electronically assisted astronomy, which is basically what we're doing tonight, they're fun little scopes to play with. I wouldn't want to do only that. I like to do visual stuff too, in addition to imaging. Oh, I heard a ding, by the way, so we better hop back to ACP. There we go. Oh, whoa, look at that. 78,792 stars found. Holy moly. Don't mistake that with the focuser position. They're kind of similar. There we go. 363 stars matched. All right, here we go. Here's Colander 39, or if you prefer, Malo 20. So 1, 2, 3. Ooh, pretty. So it's a very sparse cluster. So what do you think of that one? Everyone's very quiet. No oohs and ahs?
We don't see it.
Don't say
Oh,
it.
you don't? Ow! Did I screw up the share?
Yep.
Okay.
It says you started screen sharing.
How's that?
Not yet.
No joy.
Oh, I know it says my internet was acting weird, which is strange. It was really, really fast yesterday. All right, let me stop sharing, and I'll try to share again. Maybe that'll help. How's that?
Richard Bell has started screen sharing. That's what it's saying, and it's clocking.
Uh-oh.
You'll lose the internet out to Arizona?
Not that I can tell. I'm still connected to AnyDesk to the remote computer.
There we go. There we go.
Oh, okay.
Ooh,
That's very nice.
Wow.
Ooh.
Whoa.
Whoa.
The
Doesn't
lane
look
is beautiful.
sparse at all.
Oh gosh.
Mm.
Yeah, we're looking right into the Milky
Couple
Way
of stars.
too. So all those dimmer stars in
Wow.
the background are background stars.
That's good.
Very
Though.
nice.
Okay.
Very good.
All right. I do see it on YouTube now. But yeah, that was weird. Oh, and hello to the 15 people joining us on YouTube. They're so shy and quiet that they went to YouTube instead of Zoom. There's plenty of room here on Zoom, people. Oh, and Brody says when you decide to switch software, you should consider Nina and PhD too. But we can't use Nina because we need a program that can have different accounts that members can create to log in. So we're going to use one called Voyager. It's developed by an Italian astrophotographer, and for a little extra fee, we can have the same system where members can have their own accounts to log into the telescope. So yeah, I know Nina is very popular, but doesn't quite work for our needs, unfortunately, unless someone creates a custom version of it, which I guess is possible. Okay, so anyway, the brightest member is the second magnitude Merfac, which I pointed out earlier. That's Alpha Persei. That star right dead in the center, that's a spectral type F5IB, which is a white-yellow supergiant. For comparison, remember the spectral type goes OBAFGKM, O be a fine girl, kiss me, which I know is dated, but it really helps people memorize the spectral sequence. So OBAFGKM. So the sun is a type G star, G2V specifically, the Roman numeral V, which means it's a main sequence star. So the fact that this is an F5 1b, that means it's a supergiant. So it's no longer on the main sequence. It has a mass of 8.5 solar masses, a radius 68 times that of the sun, a surface temperature of 6,350 Kelvin compared to 5,800 Kelvin again for the sun, 5,000 times the luminosity of the sun, and about 510 light years away. The cluster itself has a diameter of about 140 light years with about 517 identified members. I'm sure many of the bright ones are the brightest members, and there might be fainter stars that are also members, but they're difficult to pick out amongst the stars in the Milky Way. And several of those members are blue B-type stars, which I'm sure are many of these, the really bright ones, just not Merfac, it's probably closer. And this has an estimated age between 50 and 70 million light years, or not light years, but years, 50 to 70 million years, which is really, really young for stars, but pretty average for like a cluster, because they don't last forever. At least most of them don't. M67 being an exception to the rule. That one's like 4 billion years old, which is unusual for an open cluster. All right, so there we go. There's the Alpha Persei cluster. We'll go ahead and close that. I hate to not share it anymore because it took so long to get it. So let's go to our next target. Everyone should be familiar with our next target, and was just mentioned here a second ago. So I think we'll go ahead and stick with 5 minutes. Might be a little on the long side because it is a bright one, but what the heck? Let's go ahead and do 5 minutes. So I did hit get coordinates. I always forget because I'm talking here. I can't walk and chew gum at the same time. And there we go. Looks like it's off. So hopefully the share works better this time. So we should be back on the KS logo there, I hope. And so our next target is M45, the Pleiades. Everyone knows this one. So of course, it's very famously referred to as the Seven Sisters, after the 7 doves that carried ambrosia to the infant Zeus, or to the 7 sisters who were placed in the heavens so they might forget their grief over the fate of their father Atlas, condemned to support the sky on his shoulders. The 10 stars are brighter than 6 magnitude. So it's very famously known, of course, as the Seven Sisters. Most people can probably see 6 stars fairly easily, maybe 4 to 6 stars fairly easily. But Stephen James O'Meara, the popular writer with Sky Telescope, author of many books, he once logged 17 Pleiades from Cambridge, Massachusetts. Heavily light polluted Cambridge, Massachusetts. So, he's one of the best visual observers of the modern time. But heck, if he can do it, I think anybody can do it if they concentrate and focus enough on the Pleiades. So next good clear night, no matter where you are, no matter how bad your light pollution, maybe except Chicago or New York, I don't know. See how many Pleiades you can spot with just your eyes alone. Maybe you won't get the 10, but it should be pretty good. So, of course, this cluster has been known since ancient times in cultures across the world, including Chinese, Japanese, Persians, Mayan, Cherokee, Aztec, Sioux, and Aborigines. The Japanese mentioned it as Mitsubishi, which means 6 stars, and documents dating back to the 8th century. And of course, they also know it as Subaru, meaning coming together or cluster. And of course, there's a very famous car company with that name, with the little emblem of a star cluster as their logo. And this is also mentioned in the Iliad, Homer's Odyssey, the Bible, and the Quran, amongst other texts. So, of course, it's been heavily observed throughout history. It is very easy to find. I've seen, like, posted on social media, people take shots of it with their phone and like, what is this? What is that? Of course, everyone would say it's the Pleiades, welcome to learning the night sky, Many people mistake it with the Little Dipper because it does look like a little mini dipper in the sky. So I guess we have the Big Dipper, the Little Dipper, and I guess the Pleiades, if you want, you can call it the Mini Dipper, but why not? It's just another name. So it's pretty easy to find on the back of Taurus the Bull here, because that's where we find it. And you can even use the Sky Atlas to find it, the Jumbo Pocket Sky Atlas to find it, but heck, it's easy to find. And one of the really cool features of Sky and Telescope's Jumbo Pocket Sky Atlas is they do have close-up charts of certain regions, and one of those is the Pleiades. So, of course, with the Takahashi, we will take in this whole region here. We have done the Merope Nebula with the 20-inch a couple of times, and that's a really spectacular region. In fact, that's the first region we ever imaged with color with the remote telescope. I don't have it handy, though. Sorry. All right, so let's go ahead and see how we're doing. Hopefully my internet is better. If I would have known it was going to be a problem, I would have checked it out earlier, but it was working really, really great yesterday. Oh, here we go. So we had to slew a bit. But we're still guiding. We're just doing a 5-minute exposure, so that's not too bad. Oops.
Hey, Richard, I got a question for you.
Sure.
Was it true about the Pleiades that it was used as for the Roman soldiers as a naked eye test? I've heard
Yes.
that before.
I think that was more, yeah, they may have used it to see how many stars you could spot, but I haven't heard that. If I heard that for the Pleiades, I don't remember it specifically, but I know that was used for Mizar and Alcor. If you could see the components of Mizar and Alcor, that means your eyesight was good enough to join the ancient Roman army.
Okay.
I'm not sure if that's quite true for the Pleiades.
I heard that somewhere along the way, but I can't even remember who
Yeah.
I heard it from anymore.
And I saw that somebody raised their hand. I don't know. I don't know who was that. I gotta scroll back to the top here. Oh, Steve. That's right, Steve McGuire. So, Steve, if you had a question, you can go ahead and unmute yourself and ask, or I'll try to find it in the chat. Or
No,
maybe
sorry,
you
I was
can-
trying to hit the chat button and I hit the raise hand on accident.
Oh, that's okay. That's kind of what I begin to wonder.
Hi, Richard. Just going back to what we observe, I'm on the edge of Philadelphia, so it's a Bortle 8. So for me, open clusters and globular clusters are great visually. And
Yeah.
then when I've gotten into astrophotography, narrowband has really helped. So I've been able to, use a H alpha and oxygen and be able to get the Western veil and things like that. So it's that's in the city. That's what only thing you can get.
Yeah, that's true. Let's see. Sean says that the Voyagers, speaking of Voyager, the different Voyagers, the spacecraft, are his favorite missions, that they're mine as well. That's what I grew up with. Older folks, for them, it's all Apollo. For me, growing up in the 70s and 80s, it was all Voyager. And yes, as Tim answered correctly, you'll be able to download these images later, as soon as I process them. And yeah, so people are talking about the C-Star 30 and the C-Star 50. They are very popular. If you are a member, we do have a C-Star 50 for loan. Of course, you have to live in the area. We're not going to ship it to you.
Yeah.
All right. Oh, there. Oh, it's upside down. Oh, no. I'll flip it over later. When I send you the processed version, I'll upload the processed version. I'll flip it over. All right. So 33,608 stars found. I wonder if that includes the really bright stars in the Pleiades. It might even ignore those because they're so bright. It's probably looking for the little specky ones. Now we wait for it to do the final plate solve. It's working. Oh, there we go. I don't know if you could hear that bonk, bonk. There we go. All right, here we go. Hopefully I'm on the ACP screen, right? All right, so here we go with the Pleiades. Ta-da!
Wow.
Wow.
Nice.
Whoa.
Oh,
got some
my.
nebulosity too.
Yeah, a lot
Yeah.
of nebulosity.
Yeah, that's great.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, you gotta wonder what 10 stars he saw.
That's my count.
12.
Yeah, so we could say there's the 4 obvious ones. 5, 6, 7, 8, 9. I can't imagine he'd be able to split these two. Maybe 10. Could be 10 here. I don't know if you can split those stars visually. Okay, so 100 million years old and composed of hot, blue, highly luminous stars that belong to spectral type B. It contains about 100 stars in a sphere about 15 light years in diameter, with a tidal radius of 43 light years, some trailing stars and such. Total population is over 1,000 stars, not including unresolved spectroscopic binary stars. It's estimated that the cluster will survive for about another 250 million years. Because what happens, of course, is maybe some of the more massive stars. So, like if this cluster had any type O stars, the most massive of the main sequence stars, they're already dead. They're gone. At an age of 100 million years, the most massive stars, like type O, they're long, long gone. And so this is one way we can date clusters is look for the most massive surviving main sequence stars. And that's, of course, a whole class to describe how we do that, which, I've done. And you can possibly check that out for a small fee. Just a quick commercial there, I guess. But what happens is, of course, yes, these stars are gravitationally bound, but kind of weakly so. And so as they encounter other stars or maybe gas clouds, which is what's happening to the Pleiades, they will lose their members over time. And then eventually the entire cluster will just dissipate. So, of course, the stars like the sun will eventually survive and leave the cluster like the sun did. The sun may have been part of a cluster very much like this, but it is no longer part of the cluster. Open clusters very rarely last 5 billion years, which is the approximate age of the sun. Again, M67 is the exception at 4 billion years old. Some people even speculated that the sun came from M67, which is, again, highly speculative. There's no evidence to support that. So, of course, what we see here is the nebulosity is a reflection nebula that surrounds the brightest stars. And this was once thought to be leftover material from the cluster's formation. And I can remember, many of you know who Dr. Kurt Karista is. He's the local professor of astronomy at Western Michigan University. And many years ago, when I was a student at Western getting my physics degree, I was in the library and read an article in the Astrophysical Journal that discovered where they mentioned they discovered that the Pleiades and the dust cloud are moving in different directions. So that means they can't have a common origin. So the nebulosity that surrounds the Pleiades is not from leftover material from their formation. It's just that the Pleiades is plowing through what's called the Taurus Auriga complex of dark nebulae. And that's also helping leave stars behind. And if you do look in very deep exposures of this region, you can literally see where the cluster is plowing through the thick dust cloud. It's really remarkable. You need a much longer series of images than this to really reveal that. And it does contain many brown dwarfs, failed stars, and that actually makes up about 25% of the cluster's total population and less than 2% of the mass. But I forgot to finish my story. Is I told Kirk Karista that the gas in the Pleiades is not related to the cluster, and he didn't believe me at first. I'm like, well, dude, read it in the Astrophysical Journal. But now it's a very commonly accepted fact. But I was the first to break it to him. He kind of took it hard too. All right, so that pretty much concludes our night with the Takahashi. So let me scroll down here. Well, I gotta clean this up. There's a lot of stuff there. So we'll close. Oh, I shouldn't have hit close. I should have just hit fold, but oh well, whatever. So now we're gonna switch back to the CDK20. But before I do that, because many of you know, I always forget, we're gonna go into ACP here. And go into the preferences. Now, hopefully with Voyager, we won't have to do this because it sounds like it's better equipped to handle multiple telescopes than ACP is, which really isn't at all. We'll put in 508 for the aperture and 3454. That way the plate solving will work with the bigger scope. So I'll do this the long way so you guys can see what I'm doing. And now we'll switch from the Takahashi to the 20-inch. And it looks like it's working. Okay. Takahashi is shutting down. So yes, indeed, we will now use the big scope, our flagship telescope, the Planewave CDK20 telescope. We technically have two of these right now because a member that passed away roughly a year ago this time donated one he used in his backyard here in Kalamazoo. We do have a buyer for that, and that's going to help pay for a lot of our upgrades over the course of the year. So this is a 20-inch telescope, meaning it does have a 20-inch primary mirror. It is a corrected Dole Kirkham. So with a Dole Kirkham, we have an ellipsoidal primary and a spherical secondary mirror, but the C part, it means it's corrected, so it has a little lens group at the back. And you can see it pretty much has all carbon fiber construction. And I keep showing this. I need to get an updated picture of this, but this is our old imaging train. We have since removed the on-axis guider, and now we have the filter wheel and the CCD camera here plugged directly into the telescope, and the auto guider here is now connected to a guide scope. We probably will eventually go back to an off-axis guider, but right now we're using just a separate guide scope. It's kind of worked somewhat well here and there, but we have had some issues with it. And of course, what carries it all is our software bisque Paramount ME2. It is a very accurate mount. Of course, we do use plate solving to make sure objects are in the center, but Even if we didn't, objects are always somewhere within the field of view, not necessarily centered, but they're always within the field of view of our cameras. So it is a very accurate mount. For the most part, we've been really, really happy with it. Maybe a few complaints here and there, but you can say that for pretty much anything. All right, so I think we've switched. Let me hop back to my browser. Oh, there it is. And yep, we have successfully switched. Hopefully the focus is okay, because I mentioned in the chat, the reason we started a tad late is I had trouble focusing because the preferences for our for focus max were gone for this telescope. The file was still there, but for some reason it didn't connect to it anymore. So I had to load that, and still it wasn't working. So I'm not quite sure what the issue is, but we'll go back and check that out. But when I did a few test shots, the focus looked reasonably good. So I think we'll be fine. All right, so our next target is NGC 206. I'm going to hit get coordinates, but I want to frame it just right. So I'm going to tweak the coordinates a bit with some custom coordinates. And call that 44 and 52.15. Okay, we'll go ahead and stick with 5 minutes with the luminance filter. And we'll hit acquire image. There we go. All right, so perhaps NGC 206 isn't exactly a household name, but that's what the PowerPoint slides are for. So NGC 206, it doesn't really have a name formally, but we'll call it the Andromeda star cloud, because this is a star cloud within the Andromeda galaxy. So last month with the Takahashi, I'll even show you the image we took last month. We did the entire Andromeda galaxy, but this month with the 20-inch, we'll focus on that specific region because it is kind of interesting to look at. And so this is cataloged as A78. Of course, the A is for Andromeda, so A78. And this was first noticed by William Herschel in 1786. And it is the brightest star cloud in the Andromeda galaxy, at least it's viewed from Earth. So, of course, we mentioned even earlier with the all-sky camera where the Andromeda galaxy is located. We mentioned it last month when we took a close-up with the Takahashi. But if you're just joining us tonight, you again start from Alpheratz, which is one corner of the Great Square in Pegasus. And just kind of start doing the star hop with the two arcs of stars here. Just go kind of to the first arc, the first star on the arc, the second one, and you can see these two stars kind of point right at the Andromeda galaxy, but we're going to go just a little askew here, and we're going to focus on 206 right there, which is shown on the Pocket Sky Atlas. So yep, M31 itself is located about 1 degree west of Nu, right there, this guy right here, Andromeda. And NGC 206 is located about 42 arc minutes south-southwest from the center of M31's nuclear bulge. So this is Andromeda's nuclear bulge. This is the image we took last month. And for those of you that did join us last month, we had some high, thin clouds. So that's what all the glowy stuff around the stars is. We imaged these stars through thin clouds. So again, the central bulge, and this is the star cloud right there. So we'll kind of, the 20-inch should kind of focus on roughly this area here, I think. That's pretty approximate. So there we go. All right, now I bet it took a while to get there. So let's see how we're doing. Yep, we're still slewing. So we'll just kind of let that do its thing here for a minute. And no, I don't want to upgrade Focus Max. No. We'll just hide it. All right, looks like we're getting a guide star. I believe guiding. There we go. Well, let's hop back to any desk here. I had to clean up the screen here a little bit because it always gets messed up after we switch telescopes. So still clear, still calm. Boy, we've gotten lucky with the wind this season. We did last season too. Last season, if you joined us, was like the perfect season. Every night was just great. Of course, last month we had those high, thin clouds, but it didn't really hamper things too much. The wind's been holding steady. The humidity's still at 59%. That's pretty good. Let's go back to the browser. Let's see how the all sky camera is going. Looks pretty good out there. Oh, you can see all of the big dog now. So of course, Sirius is the dog star. You can say it's his heart or maybe his nose because there's like a triangular head here. That's one way to draw it. Then like a little stick body, kind of a leg here, and a little tail. Sometimes you can give it a longer tail too, if you want. So if you had a dog with a short tail, you can give it a short tail. If you have a favorite dog with a long tail, you can give it a long tail. You could probably even give it a curly tail if you have like a husky or something. So, boy, you can really see kind of the dust. I'm guessing this is dust. I don't think that's sky glow because sky glow is more green. This looks like brown dust. So it is a bit dusty down there right now. But it looks pretty good. The guy, the neighbor has turned off his light. I think I even see some really thin clouds in the south there, but still looks like a pretty good night. Not much in the way of wind. But if we scroll down here, you can see the cloud sensor graph. Of course, it's very dark. The wind's very low. You can see the humidity and the ambient temperature. Pretty cold out there tonight. And you can see it's light blue on the clear sky chart, which means it's a terrible scene. Well, it looks pretty good. The guide stars aren't bouncing around too much, so it's not too bad. Maybe it's better than the forecast. So it looks pretty flat. So it looks like we got more discussion, or maybe that's done with the sea star. Yep, still people talking about the sea star in the chat. Oh, and yeah, Stan asked what's the field of view of the telescope. It's roughly equivalent to the full moon. Yeah, that's what Tim says here, about 0.6 by 0.6 degrees. That's pretty much dead on there. Yeah, Tim had some rotten weather when he was out there, but he got a great image of the Horsehead Nebula. So you can go to our Facebook page, and I posted Tim's image of the Horsehead Nebula on there. I got to post more astro photos from members, but of course, there's always so much going on. So it looks like we're imaging away there. Another neighbor with his light on. They always seem to be pointed directly at us. We're almost there. I remember when we installed the telescope in December 2015, the weather was pretty rotten pretty much the whole time we were there. We barely got to see the sky when we were there. Maybe kind of one night around New Year's Eve, we could see Orion a little bit. I remember an old article from Astronomy magazine when they were talking about Arizona Sky Village, and they mentioned there's over 300 clear nights a year, or 330. That's not quite right. It's still better, way better than Michigan, but maybe not quite that good. All right. All right, we're done. Can you guys hear my squeaky chair? I'll have the WD for that before next month. Oh, there we go. That certainly looks like Andromeda up close. Oh, look, only 6,770 image stars found. Of course, there's probably billions of stars in the image. They're just so close together, you can't make them out. So the count's off a little bit there, but it's at the limit of our telescope. I think Michigan has more than 2 clear nights a year, Kevin. Jeez.
Last night ended up being beautiful. I was out there until almost 3 a.m.
Oh, really?
Yeah, it was over, at least over here on the west side. It was really nice. No, not
Okay.
much wind. It was very still. It's great.
90 stars matched. That's not many. Of course, we're looking way out the Milky Way into another galaxy. All right, are we ready for NGC 206 in the Andromeda Galaxy? Here we go. There it is. That is
Very nice. I like that.
Ah.
really cool structure in the galaxy, too.
It is.
Almost kind of looks like rivers.
And we can resolve some individual stars in the star cloud, too. That's really remarkable.
Yeah.
Yep, these are stars in another galaxy. Isn't that amazing?
Blows my mind.
So NGC 206 spans about 4,000 light years. I'm guessing the long way anyway. It contains more than 300 stars brighter than minus 3.6 absolute magnitude. Not apparent magnitude, but absolute magnitude. The youngest massive stars are less than 10 million years old, which again is young for stars compared to the sun. It was originally identified by Edwin Hubble as a star cluster, but today, due to its size, it is classified as an OB association. So an OB association is like a star cluster in every way, except it's not gravitationally bound. And so it's located in a zone free of neutral hydrogen and does have a double structure. And you can kind of get a sense of that from the image. It's kind of like one section here, one section up there. So one region has an age of about 10 million years old and includes several H2 regions in one of its borders. And the other has an age between 40 million years and 50 million years that includes a number of Cepheid variable stars. I don't think any of them are the one that Edwin Hubble discovered in like 1922 that made him realize that the Andromeda Nebula is in fact the Andromeda Galaxy. It was probably a whole different Cepheid. But that would be cool if it was in the star cloud, though. We could say, hey, it's that one right there, but I don't know. So there you go.
Hey, Richard,
Yeah.
that's the first time I've heard that mentioned about in Andromeda having that in there. Everybody looks at the big Andromeda galaxy, but not the little details within.
Yep. And
fascinating.
if you're really a really skilled observer, one thing you can look for is G1, one of Andromeda's, or if not the largest globular cluster around Andromeda. It doesn't look like, of course, a regular globular cluster, but it's challenging to find it. So if you are looking for an observing challenge, look for G1. One of
Challenge
Andromeda's
accepted.
biggest globular clusters. There you go. I'll give you something to work on.
Yeah, thank you.
Yep. All right, our next target is one of my personal favorites. Scroll down here. We've done this one just once before, but I want to do it again. NGC 2261. I think we'll go ahead and stick with the 5 minutes there. We don't have to go super long on this one. And we'll just hit acquire image and let it go. All righty. So NGC 2261 is Hubble's Variable Nebula, one of the really interesting, more interesting objects in the sky. It's also cataloged as Caldwell 46 from Sir Patrick Caldwell Moore's version of a Messier catalog, basically all the really good objects that Messier missed, one of which, of course, is Hubble's Variable Nebula. There's also like the North American Nebula, the double cluster, and so on. So you can see it's located at a distance of 2,500 light years. It is actually located within the constellation Monoceros. You can see its general position there in the sky. So you can see the famous star Betelgeuse, and you can kind of use maybe the foot of Pollux, kind of draw a line and go a little south there. It's, you know, Monoceros is not a great star hopping constellation. It's kind of dim and difficult to see. So it's basically located 4.5 degrees southwest of Xi Geminorum, or Alzir. I don't think they have that labeled on here. At least if they did, they cut it off. I think it's here. My Greek letter knowledge is a little rusty. It was a lot better when I was a physics student. Or it's 1 degree northeast of the 4.5 magnitude 13 Monocerotis, which is right there. But of course, that's a little hard to find visually. So it's easier to go from Gemini down here to up here. And of course, there's the very famous Cone Nebula, which we've done with the Takahashi before. And the even more famous Rosette Nebula, which we've done with both telescopes before. And we'll probably do it with one of them next month. I'm not quite sure which one, though. But that's one I tend to do, not quite every season, but that's another one of my personal favorites. And so this was photographed at Hale's, the 200-inch Hale telescope's first light by Edwin Hubble on January 26, 1949. Not quite an anniversary but we're getting there. And this object is about 1 light year across, so it's not really huge compared to the other objects that we've looked at tonight. So of course, here's the famous 200-inch Hale telescope. This was basically the largest functional telescope in the world from 1948 to 1993. There was a bit larger one in Russia called the BTA-6 telescope that was completed in 1976, but it never really worked very well. So most people considered the Hale telescope the largest telescope in the world from the 40s to the early 90s because it worked that entire time, unlike the one in Russia. Because, you know, the one thing NASA and stuff never realized in the 60s during the moon race is the Russians were incompetent. So that's why we won. Okay, let's see how we're doing. We're guiding away. Ooh, looks a little choppy. Uh-oh. Let's hop back to AnyDesk. Hopefully it's still on. Yep, there we go. Well, it looks pretty good. Oh, the wind has ticked up a bit. Oh, and so has the humidity. Oh, it just went up. Did you see that? Oh, my goodness. We might have to put dew zappers on the telescopes. I don't know. It's even gotten a little colder, too. Ooh, burr. Whoa. Ow, what's this? Remind me later. Go away. Remind me. Okay, there we go. Stupid Windows. Of course, we need to upgrade this computer because it has Windows 10 and we can't, we didn't qualify for the Windows 10 extension period. So probably at next month's board meeting, we will discuss getting a new computer for the remote telescope. And then we'll make the switch to Voyager too. But we got to finish the online viewing session next month, but we'll be able to do that pretty easily. Because we don't want to try to switch to a new computer and new software during a online viewing session season. That would probably be bad. That would be a bad idea. So Not too surprised to see the scene get a little choppy because it was predicted to be kind of crummy tonight. But hey, that's pretty good. Yep, so, Sean, you can reserve some time on the 20-inch. I thought you did it at least once already. I know, isn't Windows stupid, but
I was talking about the Hale telescope.
oh, okay. Oh, that one. Okay.
Yeah, give me some time on that one.
Well, you still could. It's still around. See how the sky's doing. I'm always hoping to catch a really bright meteor during one of these sessions. That would be awesome. We've never caught a really bright one before. It's got to happen sooner or later. We don't catch the space station too often, so that was kind of cool. Getting there. Oh, well, it's gotten a little choppy again. Let's hop back and look. I hope we didn't lose our guide star. That would be awful. Well, where'd AnyDesk go? I lost it. Did it close on me? Hang on. Nope, it's still open. I just don't see it. Oh, here it is. There we go. Oh, the wind's ticked up to 2 now. It's picking up, but the humidity, of course, as the wind goes up, the humidity goes down. Star looks nice and steady as far as I can tell. Of course, we haven't been watching it the whole time. Okay. And don't ask me why ACP always goes like 5 seconds over, but that's just an ACP thing. There we go. Should look like a little comma. Downloading the image from the camera, process the thumbnail. Oh, there it is. Yep, this isn't a big one, but this is a personal favorite. So I like to do this one. Got more stars this time. 13,751 image stars found. There we go. All right, so here's NGC 2261, Hubble's Variable Nebula. Drum roll, please. There we go. Oh, the guiding is a little off. Oh, bummer.
Oh, that's still nice.
Yeah. I'll probably replace that with a different version that I took earlier, since that one's got a little trailed. Maybe the wind hopped up a little higher than we saw. Oh, too bad. But there you go. You can see it.
Three-Eye Atlas in disguise.
No, it's funny you should mention that though, because I was going to mention Pete Mumbauer is with us, and many years ago, like probably 1995, we heard about the discovery of Hale-Bopp.
Right.
And not too long after we observed the Hubble's Variable Nebula, there was a point where Hubble's Variable Nebula looked just like Hale-Bopp early on. Not when it got really spectacular, but when it was just starting to get kind of bright.
Yeah. That's cool.
Yep.
I do remember that night.
Yeah. Yep. We actually observed it. I don't know if you remember, Pete. Like the day after, or 2 days after, it was actually discovered, but was much, much fainter than even when we looked at it when it looked like Hubble's Variable Nebula.
Yeah, was that through your 10-inch?
Yeah. Yep. So
What
we
year
were
was
probably
Hale Bopp again? It was 90, what, 5, 6?
Hale Bopp was it was prominent in like April of '97, but
Yeah,
it was
there you go.
discovered in '95.
Right.
It was discovered before Hyakutake in early 1996.
Those were some good times for sure observing a Hale Bopp.
Oh, it sure was.
But a wee lad.
Yeah, Taki, I remember seeing the tail over 100 degrees when it was around Polaris. It was circumpolar. That was good.
Oh yeah, I lost a lot of sleep that week when it was circumpolar. Okay, so the nebula is illuminated by the star R Monocerotis, which is a T Tauri type variable star, which is not directly visible. R-Mon, as we'll call it for short, has a smaller dim companion, and the bigger star has about a 10 solar mass mass and is about 43,000 times more luminous than the sun. Edwin Hubble was the first to realize in 1916 that the nebula also changes in brightness. And the changes shape over a period of just days and can vary by up to 2 magnitudes in brightness. One explanation for the variability is that dense clouds of dust near Armand periodically block illumination from the star that cast a temporary shadow on the nearby clouds. And the variability of Armand goes from magnitude 9.5 to 13, was discovered by J.F. Julius Schmidt at Athens Observatory in 1861 using a 6-inch refractor. So a little bit of history there for you. And if you do get online, maybe go to sites like Astrobin or something like that, you can probably find movies of this thing varying in brightness over time. It's really fascinating to watch it. And when you observe it, if you don't really monitor it, you don't really know what state you're going to see it in. So it always looks a little bit different when you observe it visually. I haven't done that in a while. So there we go. Not one of the more whiz-bang wow objects in the sky, but one of my personal favorites. It's a really fascinating object. And at one time, it looked just like Hale Bopp. All right, our last target for the night. Another NGC-er, NGC 2024. Now, we could do this one in hydrogen alpha, but it's really, really bright. And as I recall, it looks better with the luminance filter. So we're going to stick with our 5 minutes with the luminance filter. And off we go. Okay. So NGC 2024 is none other than the Flame Nebula, also designated as Sharpless 2-277. It's also known as the Lips Nebula, the Burning Bush Nebula, which is kind of similar to the Flame Nebula, the Tank Tracks Nebula, and the Ghost of Alnitak. Where these come from, I have no idea. It was discovered by William Herschel on January 1st, 1786. So it's kind of an anniversary year. And he described it as wonderful black space included in a remarkable milky nebulosity, divided in 3 or 4 large patches, cannot take up less than 1/2 degree, but I suppose it to be more extensive. So quite famously, the Flame Nebula is very near the Horsehead Nebula, just off the star Alnitak. Remember, we've got Alnitak, Alnilim, and Mintaka. So Alnitak is kind of the lower of the belt stars in Orion. And the Horsehead kind of hangs off in this direction. And the Flame is kind of hanging off just off the star here. So I think the way we frame this usually is Alan the Tack is just out of the picture because it would be blindingly bright if it's in the frame. But I think sometimes it might get in the frame depending on how it's oriented in the sky. So it is located just 15 arc minutes northeast of second magnitude Zeta Orionis, or Alnitak, which is again the easternmost star of Orion's belt. And Alnitak, by the way, is a type O star, the most massive amongst the main sequence stars. So again, there's a little notch here for the horse head hanging off here, and the flame nebula is just over here. You can see the label for NGC 204 here. Next month, we'll definitely go over here. So if you do want to see the Orion Nebula, you can come back next month. That would be wonderful. All right, let's go see how we're doing. All right, we're already guiding, so we didn't have to do a meridian flip, obviously. So that's good. And while we're waiting, I'll do some of the in stuff here. Here we go. So, of course, if you do live in Southwest Michigan and one of the counties in red, you can join the Kalamazoo Astronomical Society and learn to use the remote telescope. But of course, I don't want to discourage anyone from doing it. But remember, if you read the manual and watch the video when we do the upgrade, you're going to have to do it all over again. But if that's okay with you, that's totally fine. Because again, we're going to do some major upgrades to the remote telescope this year. But you can help support that by subscribing to the remote telescope and use it. So there you go. And so you can join us for our next online viewing session. I'm going to post a bunch of links in here for the next slides. I'm just going to do it all at once. There we go. So, of course, you can click on the link right now and register for the February 14th online viewing session, perhaps a special Valentine Day installment. I imagine we'll have to do the Heart Nebula just because it's Valentine's Day, unless we get clouded out. But we've done the Heart Nebula before, but I guess maybe we have to do it on Valentine's Day. So there we go. You can join us hopefully on February 14th if the weather's good. If not, we'll go for February 21st. Again, the start time is 9 p.m. It's getting light. It's staying lighter later, so we got to start a bit later. If you are not a Kalamazoo Astronomical Society member and you are not on the online viewing session email list, you can click on the link that says, OVS email list, and you can join the email list for the online viewing sessions. You can receive reminders about the sessions, the registration and YouTube links, the link to download the images, which are, of course, not available quite yet. And you'll get a notification of any postponement or cancellation. Fortunately, we haven't had to post one of those in quite a while. So I think the link works. But if the link doesn't work, because I didn't check it this season, you can use the QR code, or you can just email us at our email address here, or you can use our contact form on our website. And I do want to mention the Introduction to Amateur Astronomy lecture series begins next Saturday, January 17th to be exact, and it continues on Saturday, January 31st. And if you've never taken the Intro to Amateur Astronomy series before, I highly recommend it, not just because I created it and I host it, but it's very informative, at least I think so. It's basically been refined over the course of 25 years. I did the first one around 2002 or so, and I've done it like 9 times now. Each time I make lots and lots of changes. So it's been in development for quite some time, and I think I got it down pretty well. So we currently have roughly over 540 people that have already registered. There's definitely room for more. So be sure to join us. And if you do attend all 5 sessions, you can earn a coveted certificate of completion. You can only get that by attending all 5 sessions on Zoom live. The YouTube recordings do not count. You got to attend live. Okay. And be sure to join us for our next general meeting, which is another 90th anniversary special event. Professor Christopher Stubbs from Harvard University will talk about the Vera Rubin Observatory, kind of a super duper remote telescope of sorts. Of course, there's plenty of staff there at the observatory, but there you go. Okay, so let's keep it there for a minute because it sounds like our image is done. So let's run back to ACP here. Oh, and it looks like Alma Tech is in the frame this time. All right, so here's our final image of the night. NGC 2024, the Flame Nebula. This one's awesome. There we go.
Oh, that's sweet.
That's
Ooh.
very
It
nice.
is nice.
Wow,
Very nice.
wow.
Best of the night.
Yeah, we had to end on a humdinger.
That you did.
All right, I'll come back to this, but I want to finish up here. I know a lot of people are gonna log off here.
Yeah, that's awesome.
So, of course, be sure to join us on February 6th for Professor Christopher Stubbs. He'll talk again about the Vera Rubin Observatory, which should be very timely around that time because it should be coming online here very soon and doing its mission of imaging the sky, the entire sky visible from its site every 3 nights or so. So please do register for that or join us live at the Kalamazoo Area Math and Science Center. And I did post the link to download tonight's images in the chat. But remember, if you're a KAS member or you are currently on the online viewing session email list, you already have the link in the email that I sent out earlier this week. But you can copy this link, hold on to it. Don't try to use it now because, of course, we just took the images. I haven't even downloaded them yet. I got to process them, and then I will upload them. I might try to do it tonight, but it's been a long day, so I don't know if I'll do it tonight, but I will have them on by roughly Monday night. So if I don't have them on by Monday night, by Tuesday morning, go ahead and email me and saying, hey, where are the images, you jerk? Because that means I need to get my butt in gear. So I will do my best to get those online, but I do have a lecture series to get ready for too. So let's go back to the image again just one more time, and just don't forget, you will get to download the full resolution version of these images, a little better processed than what you see here. So they should look even a little more spectacular when you download them. All right, so that brings about another close of an online viewing session. Again, I hope you join us on February 14th for the final online viewing session of the season. So that's it for me. Richard Bell signing off.
Great job, Richard. Thank you so much, sir.
Thank you very much. Appreciate it, everybody.
Thank you, sir.
Thanks,
Have a
Richard.
good night.
Good job.
Thanks, Richard.
Now you guys are vocal. Jeez, come on. It took you all night to get warmed up.
Yeah, have a good night.
Well, it's cold in places, so.
I'm pooped. I'm gonna go to sleep. I'm gonna kick back here. You guys just chat amongst yourselves. Oh yeah, there we go. Here, we'll turn the webcam down here a bit, so I can lean back. Oh, there we go. That's pretty good. Turn off the PowerPoint.